So tomorrow's going to be the end of the 6 weeks. Remember, you have one more opportunity if this applies to anybody. If you want to come in to retake the exam from Monday, so by 8:05 a.m. tomorrow, I do open the door at 7:45, but I'll probably go ahead and open it maybe a little earlier, maybe 7:30, 7:35, because it is going to be the last day. But I thought it would be a good opportunity. My initial idea was to go ahead and move ahead with chi-squared, but I think I'm going to go ahead and wait until next week to do that. That way we don't have the weekend in between. We can just keep going every day. What I'm going to go ahead and do tomorrow is I've put together some released test problems over the material we've been looking at. So you can kind of start to get an idea of how these questions are going to be asked of you, what they're going to look like, and I'll kind of talk about the marks and things like that. But I figure I'll give you probably half of the period tomorrow to go ahead and take a look at it individually, and then we can go ahead and start looking at it together. We have cumulative frequency, standard deviation, normal distribution, all that good stuff. In fact, this problem right here, I know we're doing it a little early, but we're only a couple days away. This is going to be the first focus activity for the second 6 weeks. This problem came directly off paper exam 1 from 2014. Okay, so not too long ago, but it covers exactly what we've been talking about recently. And I think the one I have for part 2, or focus activity number 2, is a histogram from the same exam as well. So just a quick idea about the tests, since we're already talking about them. You're going to have an hour and a half for each of those. You'll be allowed a calculator, bless you, on both of them. So I'm still going to go ahead and show you by hand, but it's really the keystrokes when it comes down to it. Being able to use the technology is what's really going to help you, because doing it by hand, the 90 minutes is not going to be enough time. Do you know how many questions are on paper 1? Oh, that's paper 2. There we go. So paper 1 has 15. Now, those are pretty straightforward. They don't have a whole lot of parts. They might have 2 or 3 parts. Bless you. Maybe cover a couple of topics in a single problem. But when it gets to paper 2, you only have 6 questions, and they're much longer. You have many more parts, and you could easily have 3 or 4 different ideas within the same problem. So that one's definitely a lot more specific. This one, I would say, paper 1's a little more general. So what you're going to see here, it'll always tell you the total number of marks, and whoever is going to grade your paper in IB has a rubric that they go through. So there are different things they're going to follow. Depending on your answer, you may or may not be awarded points. Like for here, okay, write down the coordinates of the mean point. Remember yesterday we were calling that the grand mean. You'll get 2 marks for that. Okay, so this problem was a total of, I believe, 6 marks. Okay, but when it comes to the marks, a good rule of thumb, a lot of times they will be looking at your work. Say if your answer is wrong, you could still potentially get points for the work. Even if the work is wrong, they have the idea of error carried forward. So they will go ahead and look at that. So maybe you used the wrong strategy, but you still did it correctly. You can still get points for that. So the marks is a good way to think about how much work should I show. However many marks you have, one less than that should be the number of steps you show for the work. Okay, so if you have a question that's worth 4 marks, probably 3 steps of work to go ahead and indicate where you got your answer from, your justification. If you only have 1 mark, those are where you don't have to show any work at all. The answer should be right there in front of you. You don't have to do anything. So it's probably going to be graphical or something very, very easy. Okay. Does anybody have any questions about the paper exams? The closer we get to the end, probably I'd say beginning of April, definitely by mid-April, we're going to be done with the curriculum in here. We're going to go ahead and just start taking practice exams. We're going to be reviewing, because there's going to be all this stuff from the beginning on those tests. So if you have any questions at any point, let me know. One other thing I want to mention, what's happening next Thursday? There you go. Your outline is due. So if you have data to go along with it, so you can kind of demonstrate to me what strategies you're using, basically the more feedback you can give me, or information you can give me, the better feedback I can give you. okay, when it comes to your IA. But really, I'm looking for more like you thinking about how you're going to structure your paper. You know, what's your topic or your thesis statement? How are you going to break it up? Like, what math strategies are you going to use? Okay, and again, if you have any questions, please don't hesitate. So let's take a look at this focus activity and see what we have here. It says, consider the following set of data, which is plotted on the scatter diagram below. So we have no idea what these represent. We just have two quantities. So they've already plotted them for us. Okay. And now in A, it says write down the coordinates of the mean point. Okay, this is what we were referring to as the grand mean. So somebody help me out. I need the average of all the x's, and I need the average of all the y's. Hey, 6 and 13. Perfect. That's exactly right. Okay, so 6 and 13. So probably on this one, if I were going to show any work, I would probably write down something like this, you know, x mean equals, and then show at least the sum, or show that you're taking the sum of all the numbers. I don't know why that keeps popping up. So 2, 4, 7, 12, 2, 4, 7, 12, 4, 8, 9, 2. Okay. 8, 9, 2. All divided by, and how many do we have here? 8. Okay. And that gives me 6. I mean, I know it might seem a little tedious to go ahead and do that, but remember, should your answer be wrong, you could still potentially be awarded points for that. We want to try to get as many points on those exams as possible. Okay. So like one step, there we go, you'd have your answer. Okay. B, write down the value of R, the Pearson's product moment correlation coefficient for this set of data. Okay, so we are going to go ahead and use technology. We're not going to go ahead and find this by hand, but let's at least go ahead and revisit those formulas. Do you remember what was the covariance? The S sub xy. Does anybody remember? Hey, Eli. Ooh, not squared.
X minus the mean of x times y minus the mean of y.
And there we go. Over n, the number of terms you have in each set. Okay, that's the covariance. Okay, let's say, Sierra, can you help me out with the standard deviation for the x's? Yes, ma'am. The standard deviation for the x's? The S sub x? Okay, so we have one big radical. Okay, x minus the mean of x squared all over n. Perfect. Perfect. And then, of course, for the y, we're just going to go ahead and replace the x's with y's. Okay. So S of y is equal to the square root. This would be the summation of y minus its mean squared divided by the number of terms that we have. And how do these guys work together? Because this is part of what we're going to be looking at today when we revisit linear regression. Spencer? There you go. That right there is going to result in our value of r. Okay, so what is this value telling me? Like when you see the value, what is it going to help you to try and picture in your head? Libby?
It's how close all the scatter points are to like being on one line.
That's exactly right. Basically, it's a numerical value that's going to represent how close your points are in your scatter plot. So if it has, you know, like an upward or a downward trend, it can be positive or negative. So the closer, the more tightly packed they are, you'd expect a number closer to 1 or closer to -1, depending on, you know, positive or negative. So what's going to happen the further apart they are? The closer to 0, yes, until it gets to a point where we say that there's just no correlation. And even though we probably could come up with a prediction equation, it is not going to do anything to help us out. Okay, so good job, good job. With that in mind, let's take the data and let's plug it in our calculator. Okay, so right here. And let's see, Alejandro, where do I go first? The light blue one. So you want me to go down to the icons? Which one? This one? Next? There, okay, I want lists and spreadsheets. Very good. Okay, so I'm going to type in here. We don't know what the quantities are. I'm just going to type in X and Y. Remember, avoid the equals row. We don't use that. And do we have a copy of that over here? Yes, because I do not remember what those numbers are. Let's see, 2, 4, 7, 12, 4, 8, 9, and 2. Okay. And then I don't need it, but Control 7 gets me right back up to the top. 5, 8, 12, 26, 12, 14, 20, and 7. Okay. So I've got this here. So for all we're doing for B is just finding the correlation coefficient. Now in this one, probably what would suffice for the work, you are going to be provided your formula booklet, so that should be one of the items that they provide in there. Maybe if you were to go ahead and write the formula, or even just write the S sub xy divided by the product of the two standard deviations. You know, you're just kind of indicating that, yes, I do know what it is you're referring to. Okay. So how do I find that R? Okay, so go to Menu, Statistics, Stat Calculations. Two variable, yes. We'll use one variable if we have just a set of data or a frequency table. Okay. So let's see here. So now, what do I do for XList? Okay, so I'm going to delete what's there. I want to type in the headings I had. There's nothing there for the Y list, so I'm going to go ahead and make sure to put that in. There's no frequency list in this one, and it looks like everything's going to show up in column D. Okay. And then here we go. Remember you told me that the grand mean was 613. Okay, well there's the mean of the x's is 6. Standard deviation of 3.35. Okay, there's the 13. 6.58, I'd say, for the standard deviation of the y's. And here is my correlation coefficient. So 0.95. What we were just talking about, what is this having you visualize? Points that are what? They're going to be much closer together. Okay, so yes. In fact, if it hits 1 or -1, remember we call that a perfect association. All right, so I'd say about 0.95. Let me come back over here and write that down. Okay, so maybe I'd go ahead and put, you know, S sub xy over the product of S sub x by S sub y, which is about 0.95. Okay. And typically on these tests, if they don't state the number of significant figures that they want, they'll usually abbreviate it as sig figs. Usually 3 is the good way to go. I just went ahead and did 2 here, but I could put the 0 in. That would still make it count. But C, draw the regression line for y on x on the set of axes above. Okay, so this is what we started doing yesterday. So let me come up here. They've already got the points for me. So let's see if I can graph this with any accuracy at all. Okay. And let's see, I just eyeballed that. Let's see how close I got. I went ahead and did it before I put in the 613. Oh, look at that. Oh, man. That is awesome. All right. So my line does go through 613. Typically, you want to go ahead and put the grand mean first and then go ahead and draw your line so that you're guaranteed that it goes through. Okay. Or if you've had enough practice and you're a rock star like me, you know. I'm sorry, I'm going to be riding high on that for the rest of the day, man. That's cool. That's cool. Okay. All right, so we have what we need here. Now, I am going to go ahead and show you how to do this in the calculator, but why don't we go ahead and practice this again? Let's do it by hand. Okay, let's do this by hand. So Eli, what form of a line do I want to use? Starts with a P. Point slope, which is?
Y minus Y1 equals M times X minus X.
Perfect. Y minus Y1 equals M times X minus X1. Okay, so we are going to use this point right here. Y minus Y1 is equal to M times X minus X1. So my grand mean is going to be the point that I want to use to write my trend line, or my line of best fit, my regression line. It's got a lot of different names to it. So we have to go ahead and choose 2 points that we believe are either on or closest to that line as possible. Do you see a couple? Which points would you guys use? 2, 5? Okay, so let's use 2, 5. And what? Okay, 920. Okay. 920 though. Oh, I'm sorry. No. Yeah, I'm sorry. Yes. So that one looks good. Now, I did hear someone say there's another point. So what would you prefer I use? And really, I mean, it just comes down to where you draw your line and what points you believe are going to be best to give you that slope. So what would you guys like? The 920, or it looks like, what is that, 2612? Or 1226, I'm sorry. Had it backwards. What would you prefer I use? 1226? Okay. Okay. So if I want to go ahead and find the slope, okay, remember that's the change in y over the change in x. So let's see, 26 minus 5, we're looking at 21 over 12 minus 2, 10. So I'd say we have a slope of about a 2.1. Would everybody agree? Yeah. Okay. All right, now let's come on down here. Since I have all three, now let's plug in, and then we'll see how close we get with the technology. So y minus 13 is equal to, we just found the slope to be 2.1 times x minus 6. Okay, so y minus 13 is equal, let's distribute, that would be 2.1x minus 12.6. Okay. And now I'm going to add the 13 over, so basically 13 minus 12.6 will give me 0.4. So y is equal to 2.1x plus 0.4. So here's my prediction equation. All right. Now, we are going to get close. Ms. Stern and I worked this problem before you folks came in, and we did notice something, and in fact, it'll relate back to what happened yesterday. Let's go back to our calculator, because we already have the data in there. So now, if I want to see the scatter plot and get the line, so I'm going to go back to my home screen. Where do I go from here? Data and statistics. There you go, right down there at the bottom, right next to lists and spreadsheets where we originally started. So it's going to plot all your points for you, but we have to tell it where the x and the y axes are. Now you can use your touchpad if you want to go ahead and highlight or hover over, click to add variable. I always think tab is faster and better. Always choose x first. Okay, so it lines them up horizontally. Tab, I want to choose y. Okay, so there's the scatter plot that was provided for us on our paper. Okay, now how do I get it to not only show the line, but give me menu, analyze, regression, and then show linear. Okay. And this is what I was referring to. We got our slope to be what? 2.1. So I'd say, doing it by hand, we were definitely really close. But you'll notice 1.8, we got a y-intercept of 0.4. Okay, so I think by hand, you're always going to find that you're probably more off on the y-intercept simply because you're drawing the line yourself, and then you're determining based on that what points are closest to that line.
So are the
Oh yeah, I mean they shouldn't be asking you to do this stuff by hand. Okay, and you'll start to see they will have you do some, but they won't have you go through an entire process. They might have you find one little bit just to demonstrate that you could do it by hand if needed, but ultimately the technology is what you're going to be looking at. Okay, so let me go ahead and show you this though. What was our grand mean? It was 613, right? Okay. So let me go ahead and take this exactly as is. I'll go ahead and take it to the 5 decimal places. If I plug in 6 here, I want you to see something. So let me, that's not what I needed. Let me go home, calculate. Oop. So, okay. Kiana. Go, man. Okay, so it was 1.8, I want to say 6667 times 6, and then I'm going to add the 1.8. Okay. But then again, we used our equation with the 613 to go ahead and get him in the first place. All right. So I would still say that our equation by hand is going to result in some good predictions. Okay. All right. How are we doing? Okay. Oh, and Kiana, before you take off, I'm giving everybody their homework today. Because I know that's what everybody wants to hear. There you go, man. Oh, that's okay. We're just going to do that practice run on the concepts we've had so far. Okay. That I haven't got copied yet, but I'll post a copy of it to the website. Okay. Let me. No, I'm thinking there's no rush on this. It's going to count for the next 6 weeks, so let's make it due Monday. That way we have all the time tomorrow to focus on making it pretty much a review session. Okay. All right, so how are we doing with correlation? What about the linear regression? Or Louise, were you stretching or do you have a question? Oh, okay. All right. Okay, so let me go ahead, erase these. No, I don't want to save that. Okay, so we're going to put that someplace safe. So we're starting over with the next set for the second 6 weeks. So you'll get number 2 next week, and we'll just keep going. Okay. So let's see here. This is what we started talking about yesterday, and basically everything here is what we did, kind of just on a smaller scale, because remember we had this huge scatter plot that we created with these 21 coordinates, and then we once again, talked about how to do it by hand, and we found it on the technology. There's really not a whole lot left. We're going to go ahead and practice another example in just a second, but I do want to go ahead and show you this specifically. Now, the problem with finding the equation of the lines of best fit by eye is that each person could have a slightly different line. Therefore, we use a more mathematical process based upon the square of the vertical distance between the line of best fit and each data point. So they could potentially, and I've actually seen problems where this very idea shows up on the paper exams. Take a look. This is point slope. Now, they're referring to it as the regression equation, but look how they've labeled their slope. Okay, do you recognize those parts? Okay. We've got S sub xy, the covariance, divided by what? Now it's not R itself. What am I? It's just the standard deviation for the x's squared. Okay. Actually, yes, it's just the variance of the x's. That's exactly right. Okay. So the covariance divided by the variance of the x values. Okay, so I'm not going to go ahead and show it to you immediately. This is definitely one problem that I want to wait until we get closer to the tests, because it's a great way to bring this back up and say, hey, do you remember this? Okay, so that I'm going to go ahead and wait on that. But I just wanted to go ahead and bring that to your attention. That can also be used to help define the slope of your trend line. Okay, and then we have, some instructions here on how to do that, but I've already walked you through how to do it on the calculator. In fact, we already did this one on the calculator, so let's go right to this last example. It says, in a study of a city, the population density Y was compared to the distance from the city center, X kilometers, for a number of sample areas. And here are the results. Okay. So X is going to be the number of kilometers from the city center, and then Y is going to represent the population density. So it says, find the line of best fit using this data, using the formula, y minus y, the mean, equals s sub xy divided by s sub x squared times x minus x mean. And then find the correlation coefficient R, given that the covariance of the data was calculated to be negative 12.472. Okay. Now, they've already given you what? Okay. The S sub xy, the covariance, they're already giving it to me as this, right? So all we need to go ahead and do, if they're wanting us to find it using this idea, we just need what?
S sub x.
Yeah, we need to go ahead and, yeah. So what you just said a second ago, Eli? Who?
Oh, the variance.
The variance. Okay. But we can easily do that. Now, again, I'm not going to be worried about doing it by hand because we've done that, several times before, and that's weeks in the past. So why don't we go ahead, take the data, let's plug it in, but we will go ahead and use the standard deviation. We can square that and then see how well that syncs up with what we find on the calculator. Everybody's good? Okay. So that's our plan. Let's do this. Okay. Let's see here. So I'm going to come back over here. I'm going to get a new document, list of spreadsheets. Okay, so X is the number of kilometers from the city center. Y is the population density. Can I borrow that, please? Okay. All right, so I have 0.6, 3.8, 2.4, 3.0, 2.0, 1.5, 1.8, 3.4, 4.0, and 0.9. Okay, so it looks like we have 10 values. Come back up here. Okay, so 0.6 kilometers from the city center. We have a population density of 50. Does that give me any more information? No? Okay. So what do you got? 22, 14, 20, 33, 47, 25, 8, 16, and 38. Okay. Now, we're going to go ahead and work this, I guess, half by hand, half on the calculator, and then we'll go back and see what the technology says about the equation of the line itself. Okay, so how do I get the value of R and the standard deviation and the mean, all that good stuff? Menu. Statistics. Okay. Two variable statistics. Okay. So I'm going to erase this, put in X, put in Y. We do not have a frequency list here. And let's see. Okay, so I have 27.3 here. Okay. And 2.34. All right, so let me go ahead and copy that down first. So 2.34. Okay. Okay. Oop, that was my focus activity. There we go. So the X mean was 2.34. What was the Y mean again? What was it? 27.3. Okay. There we go. So 27.3. So that is going to be the equation of the line, or excuse me, the grand mean I'm going to use to write the equation of the line. And let's see here. So I want the standard deviation for the X's. All right. Now, realize that we're going to go ahead and round this, so that will have an effect on our answer. Okay, we're not going to take the entire thing. How many places do you want to go ahead and round it to? 3? So 1.125? You guys agree? Okay, so let's go ahead and do that. So I'm going to go ahead and say, let me go back over here. So calculate 1.125. I'm going to go ahead and square that. So that should be the variance for the X's, right? Now, it already told me the covariance, which was negative 12.472. I'm just using this little expression they have, we talked about at the top of this page. Negative 12.472. Negative 12.472. Okay, I'm going to go ahead and divide that by the previous. Okay. So it looks to me like I'm getting a slope of about negative 9.85. Is this what you guys are getting? Okay. Negative 9.85. 0.85. All right, so let's go ahead and figure out what my equation is. So we have y minus 27.3 equals the slope, negative 9.85, times x minus 2.34. Okay. Would you guys agree? Just like we've been doing. I'm using that grand mean and the slope we just found from this expression. Okay, so now there's a couple things I want to take care of. First, I have to go ahead and distribute. So I know for sure this is going to be a negative 9.85x. And I'm going to go ahead and take care of the rest of this in the calculator. So I'm going to say negative 9.85 times, what was it, 2 point what? 2.34. Now, of course, that's negative. Negative 2.34. Okay. So I got this, and then I want to add 27.3. Okay. So now I'm going to add 27.3. Okay. So I'm getting, let's say, 50.3. Okay. Would you guys agree with that? Okay. So plus 50.3. That should be a trend line. Are there any questions how I got that? Everybody's good? Okay. Now, let's go ahead and take a look at what the technology says. And let's cross our fingers that we get close to it. I'm not so sure about the y-intercept. I'm more confident about the slope. Let's see what happens. All right, so we have already got this in. Okay, so I'm going to go to current. Okay, so if I go back here, remember I want data and statistics. Okay, how do I get the axes again? Tab. Okay, X. Okay, tab. There we go. Whoop. There we go. Tab Y. So it's looking good so far. It does have what kind of trend? It has a negative trend, so far so good. Now let's go ahead and run through and see what our value actually is. So we're going to analyze it. We want the regression, show linear. Bam! Oh my God, look at the y-intercept. Oh, do you see that? Oh man. This does not happen very often. I'm riding high. Okay. This is cool. We got what was our slope? Negative 9.85. And they got 0.848. Whoo! There we go. Yes, that's math. All right. So good. Questions? Anybody not seeing how I'm getting anything? All right. Cool. Yes, that's what I like. Okay, now here's B. Use your line of best fit to calculate the population density given that the distance from the city center is 1 kilometer. Okay, now we kind of talked on this before. There is an idea of an extrapolation versus interpolation. Okay, and it depends on where your data falls or where the item falls within your data. Okay, so like for example, out of all these x's, what is the shortest distance we have? Okay, we have the 0.6, right? The 0.6, let me go ahead and erase this. And what's the largest distance? Okay, 3.8, ooh, 4.0, there we go. Now, it's considered an interpolation if you're asked to predict within the data. So they're asking me to go ahead and predict what the population density, remember y is going to be if this is my x. So if what you're asked to predict is inside your data, that's going to work out much, much better. So what do you think an extrapolation is? That's when they go ahead and ask you to predict outside. Now, generally, we don't like to do that because this right here, this is all the information we have. We don't know if this trend is going to continue for other factors outside of it. So the further outside your set you go, the less likely it's going to be that your answer or your prediction is going to be legitimate. Does that make sense? Okay. But this one is perfectly fine because we're looking for 1, and that's definitely inside of this. Now, it's usually okay to maybe go outside your set a little bit, but you definitely don't want to go outside a whole ton. That's why you'll see these questions, like I'm going to pass out in just a second, where it asks you to comment on the validity of your answer. Okay, based on your prediction equation, what do you think is going to happen? Is it going to be very accurate or probably not? So here, well, all I want to do is just plug in the 1. So negative 9.85. Let me get back over here. Calculate. So negative 9.85 times 1. I really could have just kept it the same. Plus, what was it, 50.3? Okay, so 1 kilometer from the city center, according to this, you should have a population density of about 40.45. Okay, there we go. And I would say, because of two things, what was our, did we even look up the value of R? I don't think we did. Let's see what that value of R was. So this is a negative 0.82. So would you say that's pretty strong or weak? I'd say that's pretty strong. So what would you say about the validity of your answer? Would you say it's a very reasonable estimation, or would you say, no, I probably wouldn't use it? I'd say it's pretty reasonable based on what we have, yeah. Okay. Good. Questions? Okay. Well, let me go ahead and pass out